trig in a coordinate plane. This is where if you're stranded on a desert island and someone were to ask you, well, hey, what is the sine of 60? Or what is the cosine of 315? How could you find that? And so that's what we are doing today. Now it all goes back to your 30, 60, 90s that we did in a previous lesson, special right triangles, except in this case, they're always going to give us, or we're going to work with, a unit circle. And that was also a previous lesson, radians to degrees, degrees to radians, and unit circle. But if you take the side opposite 31, well, you know the hypotenuse is double it, or 2, and the side opposite 60 is 1, square root of 3. Well, the same thing if you have side opposite 45 is 1, 1, 1, and 1, square root of 2. And what this helps you out with, first we'll do the basic ones. If I did something like sine of 30. Well, you know 30 is just 30 degrees, because if I 0 to 90, because 0 is always there at due west, or I'm sorry, east. So if I had a 30-degree angle, look at my sides. Side opposite 31, 2, 60, square root of 3. So if I wanted the sine of 30, remember by definition, opposite over hypotenuse. So 1 over 2. And you're done. I could even ask for tangent of 30. Tangent of 30, opposite over adjacent, 1 over square root of 3. And technically, to rationalize, if you multiply the top and the bottom by square root of 3, it simplifies a little bit for you. I could even take some of the reciprocal functions. Let's say if I said secant of 30. Still the same one. I don't know, I was drawing it. I was used to doing a different angle. But you still draw it. Might as well. 30 degrees. 1, 2, square root of 3. Now secant, remember, goes with cosine. So if you find the cosine of 30, square root of 3, adjacent over hypotenuse, and since it wants secant, you're going to flip it. So 2 over square root of 3. Same thing, I just happened to pick one that could rationalize. So 2 square root of 3 over 3. I know sometimes I allow my students to leave it this way to be a little lazy, because I know they can rationalize, but technically those are the actual preferred answers. And so you can do it whether it's 30, 60, or 45, and if it's in the first quadrant, once you find it, you're done. Let's do one more, maybe cosine of 45 before we shift it. So notice how it's called a reference angle, is always there at the origin. The triangle always goes back to the x-axis. Never, ever, ever the y-axis. Always drop it down to the x. So then put in your sides, 1, 1, square root of 2. And see, now you got it drawn. You can find cosine of 45, cosecant 45, cotangent 45. You can find any of the 6 because you've got it drawn. Adjacent over hypotenuse, 1 over square root of 2. And then quick rationalize, square root of 2 over 2. But now I know you're saying, what about if it's not in the first quadrant? Well, we've got 0, 90, 180, 270, 360. And we never go over 360. Well, we know if it's in the first quadrant, that's what we've been drawing. But what about if they give me something like tangent of 120? And I need to draw it. Well, 120 we know is between 180 and 90. So if it's between those two, to find the reference angle, you're always going to subtract from 180. And remember, always back to the x-axis. Origin, x-axis. So 180 minus 120, 60. So now put your sides in. Square root of 3, 1, 2. Because remember, it always goes back to these two. So now just find what they want. Tangent of 120, opposite over adjacent, square root of 3 over 1, which is just square root of 3. Now there's one last thing. In this acronym, first quadrant, everything's positive. Sine, cosine, tangent, of course they're reciprocals. Second quadrant, sine is positive. So that means, by process of elimination, cosine and tangent are negative. Third quadrant, tangent's positive, so the other two are negative. Fourth quadrant, cosine's positive. You can remember it by all students take calculus or whatever acronym you want. So now, where this comes into play, second quadrant, and it's tangent, well, sine is what's positive, so tangent is negative. Let's do a nicer one first. Let's say sine of 210. Well, 210 is between 180 and 270. Remember, always the x-axis, never the y, so you're always going to deal with 180. Technically, in this quadrant, you're subtracting it from 180, and so your reference angle is 30. Put in your sides, 1 square root of 3, 2, and then find what they want. Sine is opposite over hypotenuse, 1/2. And then last step, tangent is what's positive, so sine, negative. And if by chance they had wanted, let's say, cosecant of 210, you just would have flipped it. So negative 2 over 1, or negative 2. And the last ones, let's say if I said tangent of 315. Well, we know it is in the fourth quadrant. I'll go ahead and put this in there real quick. Sine, tangent, cosine. Subtract it from 180. Subtract 180 from it. And guess what we're going to do in the fourth quadrant? Subtract it from 360. Because you never ever 90 or 270. So 315, fourth quadrant. Subtract 360, 45. 1 square root of 2. Tangent is opposite over adjacent. So 1. Cosine is positive, so tangent is negative. And that's it for those. We will do quadrantal angles next. Have a great day.